Hello and welcome. I'm Shadow of Shadow Gaming, bringing you episode 3 of Programming with Shadow. Today we're going to look at conditions, so how computers can make decisions based on your data. Let's go ahead and hop right in. So we're going to start here from last time, and I'm just going to open VS Code. So here we have our hourly wage program. We stopped that before, and we can already see the construct here in what I showed out last time. Let's just go ahead and start a new program for now, though. Let's do down here to my terminal. I'm going to do cd dot dot. I'm going to do let's see what's in here. Let's do mkdir make directory decisions. There we go. So cd into the decisions. I'm going to do .NET new console. Once this is created, I'm just going to do code dot. We're going to open up a second instance because we'll come back to this other one here in a minute. Now we've got us a little starting program here. Delete the intro. Let's begin. So last time we looked at creating variables, so I'm going to create some simple variables today. And let's just do int for the moment. We might change that later. So int, so the type of variable, the name, x, what value I want to give it. I'm going to give this 3. Int y equals, make it larger, so let's make it 7. There we go. Now we created 2 variables. So now let's see how we can make decisions based on them. So in C#, there's several things you can do for decisions. So the primary one is if, however. So the way you would read this is if, and then you have parentheses here. You can or cannot. You don't have to have the space here. That depends on how you want to program it. So some things you can do, though, you can say if this value here equals this other value. There's one way. So the way you would read this is if y equals, or x equals y, then you have brackets. And then if this is the case, then do something like console.writeLine x and y are equal. So there's the case if they are equal, but you also have the case else. So if they are not equal, so if x and y are equal, then do this, else do this. Are not equal. Now if we run this, control backtick to pull up my terminal. .NET run. So presumably I should get they are not equal because they aren't. If it ever runs. Oh, I forgot the semi. Try that one more time. Not equal. So we just proved 3 does not equal 7. There's showing variables, so what you can also, if you didn't want to do that, you could say if x equals 3. So if a variable equals some kind of constant value, and in this case we should see they are equal. And they are. And this warning is just saying y isn't, it's here but it's not used. Let's try another one. There's equals, so we can also say, you can also use that. So here's the values so far. Equals, not equals. In this case, are not equal, or equal. Use the large size cursor. Now I should get the opposite of it. Now x and y are not equal. That's what we get. Another one you can do, if x is less than y, greater than. You also have greater than or equal to, or that was less than or equal to, or greater than or equal to. Those are the most common ones you can do here. In this case, x is less than y. X is greater than or equal to y. In this case, if these are the same value, in this case I should get the else. They're not the same value though. In this case, x is 3 and y is 7, so I should still get this one here. And we do. As I said, if this is a 3, then we're with the other one though, because less than is just checking strictly is it less than, so think of the numbers 3 and 3 is not less than 3, so we should get the lower outcome. There we go. Those are the most common ones you can use. If you have a let's do another thing. Let's do bool z, and let's say this is equal to true. So you can also do something like that. But that probably doesn't make a lot of sense for this example. So this is not just going to always print x is less than y, because if this is true. So what we've had before were conditions. This is just a boolean. So what them conditions do? Let me go back. What this is saying, this is checking if x is less than y, and if that's the case, it replaces this becomes true, or if it's not, it would become false. So in that case, z is just the outcome, and there's nothing it's actually checking there. So this will be condition 1 here, but that's not really that valuable for us at the moment. That's basically how you can check things. And we'll see more of them here. You can also do stuff like let's say we have a string. So string s equals O. We can also do this. So if string equals, so just 2 quotation marks. So this is just a string with no characters. So yeah, empty string. In this case, it will get this first outcome here. Change this to say then condition. Here, else condition. So we should get the then condition. Else, we do not. So why did we not? So in this case, hello has content. This one has empty string. So content here, hello, does not equal the empty string. I think you can also do the less than check, but I don't think it makes any sense here. Let's see. Okay, no, it is an error. Good. I feel like I've done that before and it's not. Maybe it's in a different language. So sometimes things are a little bit more limited. So another thing you can do here to check a string, though, is you can do something like string dot null or empty. Pass it in s. What this does, it's a method or a string here. So it's just going to say string, check if something is null or empty. In this case, empty would be just the same as this would be basically this would be similar to this check, but not hardly the same, but be similar to that. Not exactly. Here we should see the same outcome. It should be else condition and else condition. So there's other things you can do. If we have a car, let's do a car c equals c. There's also ones with it, so you can do car dot is letter c. This. So here we're asking is character C here a letter, and if it is, we should get then condition. Let's do is number. So this time we should get the else condition. There's all kinds of things here. What's happening is this is number returns a bool. So it just returns a bool if it's a number, it returns true, and if it's not, it returns false. And it works the exact same way as if we had variables here. That's a good starting point. There's other things we can do here, however. So let's do two conditions. Let's say make another variable. Make int w equal to, make this one 4. So now, let's say we want to do something here. If w is less than x, then on the inside here, if x is less than y, then so right y is the largest. So else console.write line x is the largest. Semicolons here before I forget. Make that go away just a second. Now, else if w is less than y, y is the largest, else console.write line w is the largest. So there's a much more complex example here. Now, this is called a nested if, so what's going to happen is here, it's going to check if w is less than x, in this case it's 2 less than x, in this case it is, we do the then condition, which is this, then we do another check. If x is less than y, then we can write our output, y is the largest. If it's not, then we know x is the largest because w is already smaller than x. If w is larger or equal to x, then we do a check here and a check here. There may be a problem here though. What if x and w are the same? So in that case, it's just going to happen here and it's going to tell us w is the largest. So we might actually extend that to check that again here if we wanted to. Let's do control backtick again. And let's run it and let's see. We expect to see y is the largest. Don't forget a semicolon. Comma expected. Line 1. Oh. Did forget a semicolon. Notice the error here is commas expected, but the fix is a semicolon. Occasionally, you have to be a little careful reading this to see what's actually happening. Let's run that again. And y is the largest. That's a much, much more complex case. Let's try to fit this all here and make sense. But it barely fits. But something else you can do though is you can combine Boolean. So you can say something like and or also a not. So these you can do it to do the opposite. So in this case we can say if this is the case and x is greater than y, then we print this. That'll check this here. But now we need another condition, this. Now we can say if to W to and my example is going to fall apart here. Let's hold back off this one. Let's just do two conditions for now. Else, just do that. X or W is larger than Y. Just start there first. My other example was going to get too big too quickly. Y is the largest. Change that. Let's do X is greater than or equal to. So now we're going to get the other one, which is wrong. So X or Y is larger than X or W is larger than Y. So in this case, we've made a mistake. So getting a semicolon here on W is a syntax error. So for that, the compiler can catch it and knows it's wrong. In this case, however, this is a logic error. So your logic here is wrong. So X is not, this case condition is not correct. Or maybe the condition's correct, but maybe our text is wrong. At some point, our logic's broken down. And that's a lot harder to gauge than getting the warnings or errors. Compiler tells you something's wrong, you can fix it. If it's a logic error though, it's a little harder to find and you'll have to actually test through to find it. Let's switch this back. So let's look at another thing. So right now we just have two possible conditions. We can have a third, however. So we can do else if. Let's check if W is the greatest. X less than Y and Y is less than W. So now do console.writeLine. W is the largest. And if that's, and at this point, we can say is Y the largest, else is W the largest. If neither one of them is true, then we know the last one. We don't actually need to do another check here. We can run. This should be logically correct. We should get Y is the largest. Come here and adjust their values. Let's this one an 8. Now this one's the largest. Finally, see our else condition as well. X is the largest. Or I didn't change the value. X is the largest. So there we go. There's a lot of concepts right there really quickly. So what you'll see sometimes with these is that sometimes you'll see these and it makes perfect sense. Sometimes it'll be like this and it makes sense, but it's hard to read. A lot of that's just the length of the variables too, where they're so short that they don't really tell you anything. Let's see. Do one more thing. Let's do this. Else isn't required. We never have to print else. So we can do console.writeLine. Just say program continues. So don't care what it is. So do problem found fixing. I don't know what those do, but let's just do this. We have this true up here, so say we have a variable somewhere we're getting from something. We can also say that. So maybe there's a problem and we set the whatever z would represent to true. So in this case, the exclamation point stands for not. So in this case, we would read this: if z is not true, then problem found, fixing. So we could do something in here in the if statement and continue after we've got it fixed. So here we should see both of these. Maybe semicolon. I don't know why I can't remember them. So there we go. Program continues. And is my logic wrong? It is. So I just said that completely backwards. So again, the variable names are hard. Let's do if has error there. And now I can see the problem because my variable names are better. So if it doesn't have an error, we fix the problem, and that's wrong. So if it has an error, we fix the problem. So there's just more proof that, or the better your names are, the easier it is to catch problems. At this point, we've really quickly looked at an if then else condition, an if then else, an if then else if else, and finally just an if. Those are the most common decisions you'll make in C#. Well, there's actually one more, or another one we'll look at later, but I'm going to skip it for the day. Just focus on stuff for now. So moving right along, go back to our other program here, hourly wage. What we're doing here, I'm going to control K, control U to uncomment this. So what we were doing, we were checking if this was not a number. What we were doing is we read in input from the user, then we do this double parse. So this is takes this user input here and tries to make it a double. So if you have a letter in there, it fails. So what we experimented with here is another way to do that. So if try parse. So if parse doesn't do it, it just fails. So let's just do that. Let's do run hours. So let's just say cd dot. I'm in the wrong spot. Let's go up to hourly wage. Now do .NET run. So now let's say we worked 8 hours. So in this case, we're going to get an exception, unhandled exception. Input was not in the correct. That's not really all that nice. So what we could do here is what we've done here. In this case, we say if this try parse failed. So parse just fails. Try parse doesn't fail. It returns a Boolean, and this Boolean can be used here in this if. And then this out hours worked. This is just saying if it works, we make it out hours. So it's like instead of doing equals here, we put it in out. This will do the similar thing to this line here. So let's see. So let's run it. So now I expect to get my error there instead. Hours worked A was not a number, and then we stop. And to me, that's actually nice error handling. It's something we couldn't, or our program here, we have to have hours worked and it has to be a number, otherwise the calculation here doesn't work. So what we did, we would just stop the program. So to stop it, we call this environment.exit. And I gave it a 1. When we look at what exit says, if it's a 0, it means it exited successfully, and any other numbers indicates an error. And that's just by convention, though. In reality, you could treat it as any way you want, but for the most part, that's how you'll handle it. 0's success, anything else is error. We could do that here as well. We could comment this out. Do if double dot try parse user input out hourly pay. So if that's not the case, then we'll do line. Really like to keep my other one up there. It's just a little bigger than I would like. What I'm doing up here is just I'm copying the previous. So hourly pay was not a number. Environment.exit 1. So doing very similar to what we did before. Now if I run it, we now have error corrections there as well, or error catching there as well. Let's say we worked 40 hours and we got paid a rate at A. So problem though, I picked the wrong value. So what this should be is user input. So again, that was another one of them logic issues. Technically a typo, but still a logic issue. Oops. And because it was a logic issue though, the compiler didn't catch it. I had to catch it by testing my program. So in the future, we'll look at writing or using C# to write tests that'll test our program, so it makes it easier to catch things like that. But for now, we'll just do it ourselves. So there, hourly pay A was not. There's just a little bit better handling. Another way to handle an error in this case would be to keep doing this and keep asking maybe hourly pay and just keep asking until they give us a correct value that works. In this case, we don't have the knowledge for that yet. That'll be next lesson. We'll look at repetition. So for now, this is as good as we can do. Maybe we could change the error messages. Maybe we can make it more clear, something like that. But as far as new C# stuff, we need one more lesson before we're ready to go on. So we'll have to stop it with that. That brings us to a third program. So a lot of the purpose of this is to of this series in general is that I want to teach stuff by building stuff. Here's just a little wage calculator, so good starting point. Do another simple one. So I'm in the US, so we use Fahrenheit for temperature. So I'd like to make a little program to convert Celsius to Fahrenheit or Fahrenheit to Celsius. So, or you can do that through Google, or you can Google it if you'd like. But there's calculators for that. But I'm going to make my own. Do a cd dot to make their temp converter. Let's call it that. Let's do code dot. Here we go. Here's us a program. Let's do .NET new console. There we go. I'm just going to delete this line this time. Let's change this to say, oops, welcome to Shadows Temperature. I'm just going to do a new line. No, let's not do it that way. Let's do it another way. So the way you would specify in a string to do a new line is you would put /n, \n. So this, even though it's 2 characters on our screen, as far as the computer is concerned, it's just a single character. If we do a character type up here, we could do character A equals /n. Normally it won't let us put multiple characters like this. If we do this, it's going to be a compiler error. .NET Run. This will be an error. Yep, too many characters in a string literal. It actually doesn't care about this though, and we'll see more of these later. We call them control characters though. So as far as C# is concerned, though, that's one character. And what it does is it makes you do a new line, so it printed us a new line here. Let's do 2 new lines, though. Welcome to Shadow's temperature converter. Please, let's not do that. Let's do, see how that looks. This isn't going to be what I want, but that's see if it does. So instead of that, though, get rid of that. Let's do another console.write line. So we could have combined this into the same line, but I chose not to because I want this to be a console.write. Enter temperature postfix. I'm going to put in parentheses here C or F. What I'm going to ask for is give me a letter, C or F. So when we get them from this, so what we're going to do is we're going to take that and say, if they give us a C, we're converting Celsius to Fahrenheit. If it's Fahrenheit, we'll convert it to Celsius. So let's do that. If we need to do, start here, string user input equals. I'm just going to do this in one line, so console.read. So we're going to get that warning we were getting before, but we can live with it for now. So before we were having to parse these. In this case, we're looking for a letter, so we don't really have to parse this. We can do this as a string or character without really parsing it. In this case, I'm just going to treat them as strings, even though they're a single character. So what we can do now is if user input equals C, then convert Celsius to, spell that wrong, that's an S. There we go. Modern. And here, I'm going to avoid a mistake here. What we could do here is just put the else and do it the other way. Problem with that, let's see the problem with that first. Let's do this. See that. So the problem here is that this isn't going to be exactly right. It's going to be us. It's going to be us another logic error. So if I run this, he does not exist. With the character C. Error, cannot complicitly convert. So that's telling us that what we're getting here is a string, which we know. We're saying that we can't make that a character like this. So what we can do here is instead of that, we can do, like I said, and treat it as a string, and this should work. Again, we have an error. So this one is a logical mistake. So when I typed enter here, I needed the second one. The 1 equals is an assignment, so user input gets console read line. 2 equals is user input equals. So that one can be something you'll see some. Enter a prefix, so C, convert to Fahrenheit. F, convert to Celsius. But also if we do A, it also tells us to convert to Celsius. That's wrong. So what we should do here is if user input equals F, then do this. And then here's a true error. So else console.write line conversion invalid conversion. Let's do that. Conversion. Please use either F or C. So there, that'll fix that case. So now we give it an A. We get that. Another problem, if they use capital, it's not going to work. So we can fix that as well. If we do capital F, it says it's invalid. What we can do here with user input, we can also do user input equals user input dot to lower. What this does is it takes user input here and runs this to lower method. That just makes it all lowercase. So now if we do that and give it an F, Fahrenheit to Celsius as we expect. There we go. So there's a little bit more logic that we haven't seen before. So let's do the conversion here. So to convert Celsius to Fahrenheit, I'll keep that for now. What we're going to need here is going to need to read in the temperature. So what I'm thinking, let's do it like this. I've done this in the order of you give it the number, or you give it the letter and number first. Normally I would do it the other way though, so let's do it that way. Console.write enter temperature in degrees. Let's copy string user input. Move that from here. Console.readline. So here we can do their if check again. If, and I'm only going to take decimal numbers or integers. I'm not going to take anything else. So if int.try parse user input out. Let's do int initial temperature equals 0. Let's not do that. Let's just do that. Initial temperature. So else do console.write line. Let's say temperature. Let's be a whole number. And we're good. We can remove my $sign. So there, now we'll get a temperature and it'll be a number. And we'll then tell it if it's Celsius or Fahrenheit. Let's also take an integer. Since there's division here, let's do it as a double. Let's do double final. Let's just do converted temperature. Let's make this a double as well. I said an integer. I don't see this as a problem. One thing we could do here, if we wanted to, we could do a check here and say if the temperature is in a specific range, like if we know how, like maybe a maximum or something, we could do something like that here. But I'm not going to here. We're just going to convert. Just say give us a temperature and we'll try to convert it. So now, converted temperature equals, let's do some math. Take the temperature in Celsius, so initial temperature. I'm gonna make sure I remember how to do this. Times Put parentheses 9 divided by 5 plus 32. So here, if we follow the order of operations, multiplication will be before, multiplication and division will happen before the addition, so it'll go in order. That it would be 9 times 5, or without the parentheses, it would have been initial temperature times 9 divided by 5, which is actually probably all right, but I think for the formula, this is what we want to do. So we want to do 9 divided by 5 first, and divide by initial temperature, and then add 12, add 32. I believe this will give us the temperature. Let's do this. What was the initial? Initial temperature. C is converted temperature F. We'll do that. I think that'll be. I'm going to copy this here and just do it down here as well, so we don't forget F and C. Let's add here in the middle. Converted temperature equals. So this one I believe is Fahrenheit initial temperature minus 32 times 5 knots over 9. I believe that'll get us a conversion. I might have to go look this up if these don't seem reasonable. Let's see what happens. I think this will be our entire program. Let's run it and see. Welcome to the conversion. Let's do negative 40 because it's easy. Let's do in C. So negative 40 C is negative 8 Fahrenheit. So that is wrong. Now the problem is which one of these is wrong. Maybe it is the other one. Let's try that again. So negative 40 Celsius is negative 40 Fahrenheit. There we go. So let's add another parenthesis here to make this more clear then. Now we're saying initial temperature times 9, and then take the result of that and divide by 5 at 32. Let's do it the other way and see if that works now. So negative 40 F 0 Celsius. So we got a bug here as well. Right offhand, I don't know which one it is. Maybe it's the same thing. Maybe it's this. Negative 40, negative 40. I should have looked up the formulas, but there we go. Close enough. Let's move this here to make this more readable. Now I'm saying initial temperature minus 32 times 5, and then all that divided by 9. There we go. So there's just some conversions. If I do 212 Fahrenheit, we should see 100 Celsius. If we do 0 Celsius, we should see 32 Fahrenheit. There we go. We've got us a little simple converter there. And that was not too bad. Some of this looks more impressive than it actually is. If you know the formula, this would have been a lot easier. that's pretty much what I wanted to cover today, though. So maybe we could do something more. We have a little bit more time. Do I'm trying to think if there's anything else I want to do with this program. Like I said, I could limit the number if we wanted to, but it'd be another if check. Do one more here. Let's do a nested if. If user input equals k. So k, it stands for Kelvin. Right. Not supported. There we go. So there's a nested if. In this case, I'm about to have a bug, so no, let's do that. So now, what if we give it a k? We're going to say conversion. Kelvin is not supported. Invalid conversion. Please use either that. So I think that's fine. So I was going to say I don't know if I want both of them together, but I actually think I do. There's a bug. So I forgot to add my environment. Fix it one. So there's a bug we caught by testing it. Let's do 65k. Invalid conversion. Okay. So that's pretty much enough for now. So that's a nested if, so an if within one of the other conditions. So let's read through this program real quick and we'll call it. So here I begin by, so from before we talked about the ability to place variables at the top of the program or right before you use them. Doesn't really matter. It depends on if you'd rather use them like that, you can. I did them here after my intro. That's all right too. I would actually argue that if I'm doing that though, I should do this instead. I would argue that that's probably a little cleaner than what I had here just a second ago. But so let's read through. We give us some intro, tell us what the program is, and tell us give us a prompt. Then we take this console, so we read from the console. We read a line. We store it here in user input. And we declare an initial temperature. Then we use we check a condition here. We say if user input be parsed. So if try parse is if we can convert user input to a double, if we can try to parse it, put it as a double and output it as initial temperature, the variable we just declared. But if this fails, then error out. Nice and simple. So then we prompt the user again. Now we read from we get the user's input. Now we convert it to lower. So this takes a user input. In this case, it's a string, so they can put letters in there. And we convert it to lower. So here, this could be considered a bug as well, because if they've given us a longer string, so more characters, we could do something here, like we could check the length and say if it's more than one, we're done, or we could always take the first one. We could do anything like that if we wanted to. In this case, if it doesn't match, it doesn't match. So I say that in that case, it's an error, or it's their else case. So that's what the lower is doing for us, and possible problem there. Then we have the else case inside the terminal. So this is the if then, else, if then, else. So a fairly complex one. So let's begin reading at the start. If user input is equal to C, in that case we're treating it as Celsius, Then we convert Celsius to Fahrenheit. And then we do our conversion here. And we store it in converted temperature. As you say, now, I knew generally the format for it, but I actually wasn't 100% sure on where the parentheses, which one should be done first. I got them wrong. So you see me do a little on the fly debugging. We also learned that order of operations matters just a little bit. So we might look at that more later, but putting parentheses around everything not only makes it cleaner to read, like here I know this is always first, followed by this, and then add at the end. But order of operations, where that comes from. And then we just output the number there. And then the next line we say else. So if it wasn't Celsius, then else. If the user inputted F, which represents Fahrenheit, then we convert Fahrenheit to Celsius. We do the same thing here. I've added probably more parentheses than we need, but this is still how I would do it. I'd add these outside ones here, the ones colored in pink for my editor. I'd add them just to differentiate this guy. Then we output that. And then we hit the else condition. So the else condition, we went ahead and added a nested condition inside. We say if the user inputted K, which we're saying is Kelvin, then we tell them Kelvin's not supported. Then we say invalid conversion, please use either F or. There's just a nice little program. Shows us a little bit with conditions. So as we get further along, we'll get very good with conditions because we'll see that that's how programs are powerful. If everything's just done in sequence, it can do stuff with that, but being able to make a decision is the way to really be able to do more with it, do more programs with it. And as you see, we have 1, 2, 3, 4 conditions in this one program. So as you get bigger programs, you'll see more conditions usually. So that's pretty much the end of it. Next time we're going to look at this. We're going to look at our error check here to check that something's a number. And what we're going to do there is we're going to introduce another concept called repetition. The idea here is if we wanted to repeat this, right now we'd just run the program again, or we could do some copy and paste and do it. There's a programmatic way to do it as well called repetition. In this case, it's loops. So in C# we'll look at the while and for loops. So that's a way to loop through and do things repeatedly. One of the things we can do is error checking. We might talk a little bit about error checking at that point because then we've seen 3 different ways to do it and give opinions on why I prefer one over the other 2 maybe. We'll see. That's pretty much it though. We're going to call it with that. So we're going to say thanks for watching. Have a nice day. Part 4 will be next time. Thanks.